is the adversary? Who are these people that are trying to keep us from accessing the internet? What are their goals? Why are they trying to keep us from accessing the internet? A lot of them, turns out, are government employees. And if you try to access blocked sites from 9 to 5 local time, you have a lot more resistance. If you do it on government holidays, weekends, evenings, there's no real-time response because nobody's at work. They don't have a round-the-clock stream. It would be too expensive to have a round-the-clock stream. And that comes to what are their capabilities. Like, are they just buying off-the-shelf stuff from, like a few companies in California and just plugging it into their racks? Are they doing people imagine they're doing like custom hardware and stuff, and there's a couple of people that have that capability. For the most part, it looks very much like the router, like the Linksys router I showed at the beginning. They just have like $7 million worth of like Linksys router looking stuff just in racks. And so we can find this out. And a lot of people want to do like automatic probing, like let's probe the network and like see. But you can just talk to the people that bought it and be like, what'd you guys buy? Like what routers do you have? Because they go to the same hacker conferences that everybody else does. Like they're doing cybersecurity. It's like you get people from both sides, so you can just ask them. And then what's their tolerance of risk? Like if we come up with something that in order to block it, they'll also have to block a bunch of other stuff that people like. Are they cool with that or not? Like I said before, there's nothing that's untouchable. There is an adversary somewhere that will block whatever thing you think is sacred and not blockable, but that doesn't mean everybody's going to do that. Everybody's different. They have different ideas about what the tolerance for blocking things accidentally is. So we need to know all of this before we can do any kind of like an intervention.
On their website, the Operator Foundation states, Operator makes usable tools to help people around the world with censorship, security, and privacy. During the 2019 ACTLab conference in Austin, Operator President Brandon Wiley outlined the ongoing problem of internet access in developing countries. He also introduces us to the concept of CATs, or credible and topical sources of information.
So my name is Dr. Brandon Wiley, and I work with an organization called the Operator Foundation. And thank you. There's some operator people here in the audience today. And so what we do is we make tools to help people who are oppressed on the internet. So there's a bunch of different ways that people will be oppressed on the internet. And one of the primary ways is just being denied access to the internet. And I'm not talking here about, like a natural disaster sort of situation or like a place where there is no internet infrastructure, but rather political oppression using the denial of internet access as a way to as a window into human rights abuses and things like that. There's a whole bunch of people that work on this with me. We have a whole team of programmers and designers and administrators, and the whole board's here. It's true. So I don't want to make it sound like this is just something that I did. This is a whole team that works on this. So I'm mainly going to be talking about internet access, and when I talk about like access to information, I'm not talking about like entertainment. I'm not talking about fake news. I'm talking about a specific, type of information, which is credible and topical sources of information. So things that are relevant to your life and that have some level of truth to it. And I'm going to be talking about this a lot. And so I just went ahead and made it into like an acronym, CATS, credible and topical sources of information. So if you hear me talking about CATS a lot, just like don't get distracted by the metaphor. It's like we're talking about information that people need in their daily lives in order to like be safe and to be happy and to get things done. But I'm just going to call it CATS in order to save time. So the internet, what is it? What is it for? Well, the internet is essentially just a bunch of cables all over the world. I know people think that the internet is wireless. It's not wireless because that would be require too much power and it'd be too slow. I know you think probably when we talk to other countries, we like go through like satellites. Satellites do exist, but that's not how you're talking to other countries. It's all through just through some wires. And so here's a map of where all the international wires are. So for instance, if you're in Greenland, there's just the one wire. And so if you need to get on the internet in Greenland, there's somebody you got to talk to. And, if they decide that there's no internet today, like what you're going to do because they have access to the wire. And it's not even that big. Like that's what one of the cables looks like. They go across the bottom of the ocean and connect different countries together. And some countries have more or less of them, but they're pretty small. And boats like drag anchors across them all the time and like cut off the internet of like whole countries. And it's a big problem because like international waters, like what are you gonna do, So anyway, yeah. So at the center of like why it's a network and not just, like a wire from you to me and we can just communicate peer to peer is because there's all of these routers. And I'm sure you've all seen one of these that you have in your house. The ones that run national level internet are the exact same thing. They're just bigger. So instead of like one of these, you'd have like a rack from floor to ceiling. It would have like 100 different places you can plug in cables, but the technology is the same. There's just a computer that's sitting in between the two wires and deciding where things should go. And this is where the problem comes in, where oppression can happen, which is that you can have somebody sitting here with this device and it says, some of the internet traffic is normal, it's fine, I'm gonna let it through. Some of it is weird, and I'm just not gonna allow that traffic. Who here likes to get weird on the internet? Anybody? Okay, a lot of people. So what oppressive governments would consider getting weird on the internet is things like using chat programs, using video conferencing, accessing non-government news sources, accessing any kind of social media where there might be kind of, you could talk to people that the content is not being filtered. So we all, in some way or another, like to get weird on the internet. And so, unfortunately, we have these machines that are sitting in between us and the internet and determining whether or not we're going to be allowed. So I'm just going to get very quickly into the history of censorship and censorship circumvention. So, there's been these different levels, these different eras since the beginning until like when we get today, we get this very advanced like protocol identification stuff. And so I have kind of eliminated all of like the acronyms and stuff about the internet that are not necessary to the narrative. So if it's anybody that like is like an internet, like a networking engineer, you might be like, it's not 100% technically accurate, but that's okay. So in the beginning, we just had these numbers. These are phone numbers, and in the beginning was phone numbers. Now we have the numbers are in a slightly different format, but the basic idea is the same, which is that if you want to talk to another computer from your computer, then you give it this numerical address, and then it will go find that computer. So like this is like me over here on the left, and on the right we have like Google, and I might be like, hey Google, can you give me some cats, which is credible and topical source of information. That's one of the things people use Google for, is to like find out information about things that they need to know. And so unfortunately, you can basically just put in the router and say, this numerical address is not allowed. You can never go to this website. And this is the fundamental, like level of internet blocking, which is very common and still happens today. And so, of course, you could have the computer change its number, right? And then you could, of course, now we have to remember these numbers. Does anybody remember any phone numbers off the top of your head? Some people do, right? So that's in the old days when there were only like 100 computers on the internet. You would just put in that computer's number and you would just have to remember it. But unfortunately, these are hierarchical. So you could just say, okay, well, everything that starts 650, that's Mountain View, block all of those numbers, and then they just have to keep getting more and more numbers all the time, and so that we can access them. The basic circumvention tool is a proxy, and a proxy is just another computer that you go through first before you get to the one that you can't access. So like this is a UK number, so if I were to proxy through a computer in the UK and then connect to Google, as long as the UK has different sensors that have different rules, it should be fine. So this is the first thing that you need to know about censorship circumvention. We got to bounce through some other computers, and the movies will always do it through satellites, but we don't use satellites. And then in the modern internet, we have names. So instead of remembering the number, you can like say Google. Well, how do we figure out what that means? Well, there's kind of a system. It's kind of like the phone book, and you just look it up, and then you say, okay, what's the number for Google right now? And then it'll just fill in the number for you. And so Google can change their number all the time, and it can help, with censorship circumvention. Unfortunately, the censors also have access to this name lookup service. So they'll just say, okay, anything with the name Google, that is blocked. And then it doesn't help at all. But that's kind of, the internet that you're more familiar with is the name-based internet, which came later in the development of things. So you always have to look at the addresses, like what's the number that I'm connecting to? Like the router needs that information to send your information to where it needs to go. But for a long time, they wouldn't look at any of the actual information inside of your conversation, just at who you were connecting to. And so, and it's mainly because of computational reasons, like it was like too expensive to do with computers of the time. So as computers got faster and they could process more data, they were like, well, what if we actually listened to the conversation and then we did keyword filtering? And so basically, at this point, and everyone knows that, this is happening. I say I would like some cats, and then it just says, okay, well, no conversations about cats can ever be had. I don't care what computer you're talking to. I don't care what the name of that computer is. If you're talking about cats, forget about it. And so, you might think okay, well, we'll just use code words. Like you can say kitties, and then we get the same information. This will work. If you Google kitties, you get information about cats. And again, this is just a metaphor. Don't get caught up in the metaphor. And then, they'll just update the block list and say, okay, nothing about kitties. So then you could just come up with more and more obscure names, right? And this works for a while, but you got to tell everybody what are the code words. And this is in countries where they do very aggressive filtering by keywords. People have all of this code word language to talk about the government and to talk about all the banned subjects. They just keep changing what they call them all the time. But yeah, so the question is, so what if we, this is a little bit inefficient from the censor's perspective to have to keep, updating all the time. So what if they could just train a computer to recognize anything that could possibly be cat related, and then to just block all of that without having to keep up with the latest trends? So what if we replace the whole thing with this giant creepy eyeball, which represents, artificial intelligence and machine learning? So what if we just gave it all of these cats and we said, okay, this is your block list now, is anything cat related? And so we'll call this the cat protocol. The cat protocol, a protocol is just a pattern of information exchange. So we'll call the cat protocol anything that might be about cats. And there could be many different protocols on the internet. You could have a banana protocol where we talk about bananas and, so on and so on. But so we'll just train it. We'll say, okay, block any information that might possibly be related to cats. And then there you go. Once again, we're defeated. And this is where we're at right now. This is called protocol identification technology. It's in all of the routers in all the countries. And so a lot of things that you might want to do are blocked. So for instance, using a VPN or using any of the existing censorship circumvention software, can all do this protocol identification and say I don't know where you're going, I don't know what you're talking about, but I know that it's bad, and so it's blocked, right? So then this is our adversary, essentially. So we've been working on the other side. We're working on the obfuscation of network traffic to make sure that it doesn't get blocked by these different sensors. And there's been 3 different levels of development here as well. So I want to just give you kind of a run through of those. So the first thing was this looks like nothing philosophy, where they said, listen, let's just take our traffic, our internet traffic, and let's just make it look totally random so that there's no way you could make any kind of a rule to block it. And so we came up with, this sort of looks like nothing cat. And there's a couple of things you can notice about this image that are metaphors for the whole field, which is one, you can still kind of tell that it's a cat, right? Even though it's made of white noise. And that's a big problem is people think, oh, I've totally made my traffic look random. But did you make it look random along every single dimension that you can think of? Are there dimensions you can't think of that maybe someone else can think of? Then, maybe you got it looking good in 2D, you rotate it in 3D, and then it looks like a cat again. Second of all, this is a very suspicious image. We could make up a protocol we call the noise protocol and just block everything that looks like noise. Nobody is downloading white noise on the internet. That's a weird thing to do. So we'll just mark that as weird, block it, and then it's fine. And so this is what happened. People spent a lot of time trying to make the noise look perfect, a lot of nerding out, on this sort of stuff, ultimately not very effective against the real world adversaries. So then the second thing that people started to do was protocol mimicry, where they said, okay, CAP protocol is out. Let's make things look like some other protocol. Let's pick something that's safe, some communication exchange that the machines will not find threatening, and let's make everything look like this. Or as I call it, the old cat in a banana suit trick. Yeah. So, you know, any machine that looks at this would be like, that's just a bunch of bananas doing banana stuff. Totally fine. Bananas are allowed. E-commerce, you know. And so, you know, this worked for a while, but the question is, you know, which protocols are untouchable? Like, which information will the oppressive people never, ever, ever block? And turns out there is nothing which is untouchable during, like, elections when they're trying to do some election fraud and they don't want to get caught. They just block just pretty much everything. And so there's really no like safe thing that you can pretend to be. So what we need, and this is what we're working on now, is what I call an adaptive system where we're gonna adapt to the adversary. So like let me ask you, is this a cat? Do you think so? Does anyone feel like this is a cat? Are you sure it's a cat? What, when is it no longer a cat? Like at what point, stare into the eyes of the cat, at what point is it no longer a cat? Because that's where we're going to set our settings in our adaptive system. We're going to make it just weird enough it freaks out the AIs that are running the internet, gives them nightmares, and they can't effectively do their job. And you know, so that's the technology that we're working on now. Cool. So now I want to talk a little bit about just the practical, how do we do this stuff in the real world? Like we're doing this censorship circumvention all over the world in all these different countries that have totally different methods. They have different settings and configurations and hardware and stuff. And I think people get really lost in the weeds of like the nerdy parts of how we hide the traffic. And it's really a quite like straightforward process. So we got to do some threat modeling, data collection, analysis, and implementation. Straightforward, no problem. Threat modeling, first of all, and this is something that everybody always forgets to do, who is the adversary? Who are these people that are trying to keep us from accessing the internet? What are their goals? Why are they trying to keep us from accessing the internet? A lot of them, turns out, are government employees. And if you try to access blocked sites from 9 to 5 local time, you have a lot more resistance. If you do it on government holidays, weekends, evenings, there's no real-time response because nobody's at work. They don't have a round-the-clock stream. It would be too expensive to have a round-the-clock stream. And that comes to what are their capabilities. Like, are they just buying off-the-shelf stuff from, like a few companies in California and just plugging it into their racks? Are they doing people imagine they're doing like custom hardware and stuff. And there's a couple of people that have that capability. For the most part, it looks very much like the router, like the Linksys router I showed at the beginning. They just have like $7 million worth of like Linksys router looking stuff just in racks. And so we can find this out. And a lot of people want to do like automatic probing, like let's probe the network and like see, but you can just talk to the people that bought it and be like, what'd you guys buy? Like what routers do you have? Because they go to the same hacker conferences that everybody else does. Like they're doing cybersecurity. It's like you get people from both sides, so you can just ask them. And then what's their tolerance of risk? Like if we come up with something that in order to block it, they'll also have to block a bunch of other stuff that people like. Are they cool with that or not? Like I said before, there's nothing that's untouchable. There is an adversary somewhere that will block whatever thing you think is sacred and not blockable, but that doesn't mean everybody's going to do that. Everybody's different. They have different ideas about what the tolerance for blocking things accidentally is. So we need to know all of this before we can do any kind of like an intervention. But it's just, this is like social science research. There's like straightforward methodologies for finding out this information. You just gotta put the work in and not try to just come up with stuff in your brain in the office without talking to anybody, which is what a lot of people do. So then we got to do some data collection. Once we have like the overall, threat model, it's like, here's the map of all the different things. We don't do any work in Australia, so I'm going to pick on Australia. So you can see Australia, being an island, they have like a few different pipes out, a few different cables out to different countries. And so what we would do is we would set up some actual analysis points where we're actually looking at the traffic. And the way we do that, you don't have to be like ISP or anything. Like you can just rent, rent a server or something in this part of Australia, and then just by the definition of how everything works, if you connect to your server in Australia, you're going to be going out one of these different cables, right? So if you strategically place things geographically, you're going to be able to go through each cable, and you'll be able to look at what specific blocking is happening on that cable. And you can do all kinds of experimental stuff, data science stuff, where you try different things out and see what gets blocked and what doesn't get blocked. And so we do all of this. We have a whole project called Canary, which sits around, on all these different countries, like probing the internet. And then, we do data analysis on that data. So for the analysis, we use machine learning. And when people talk about AI, they're usually actually talking about machine learning. AI is like a kind of an archaic term that have meant like 100 different things. And so these days we're like, oh, AI is like taking over and it's like doing really great. They're probably talking about machine learning. And so I wanted to talk just a little briefly to just demystify some machine learning. So machine learning is just algorithms that create mathematical models based on observations. So first thing to note, algorithms, it's just programming. It's just a form of computer programming. If you can do computer programming, you can train machine learning models. There's not really even that much like specialized knowledge you need anymore. It used to be you had to have like a PhD in it to like pick the right model and everything. These days, like if you use like Apple's AI engine, you just say, here's my data, and it will run all the different types of models that anyone has ever written a PhD dissertation on, and it'll just pick the one that has the best performance. So it's like 3 lines of code to train a model these days. You just give it like a spreadsheet, and then it just does it. So very easy to do these days. And then they create these mathematical models, which is to say, it's just a program. You're writing a program that creates a program. So it's a little bit more twisty, but it's not that bad. And the cool thing about it is that it makes this program based on observations. So basically, instead of us looking at the data as experts, as like network protocol experts, truly understanding it, and then writing a program that embodies that knowledge, we can have a kind of like a higher level sort of view of it and just have the program write most of the details of itself. So here's an example of like some actual data. From my dissertation. So on the left is what the machine that blocks internet access would be considered normal, and on the right is what it would be considered weird. Now I could explain to you like how I got all of this data and like what it means, but that's not really that important. What's important is you can tell just by looking at this slide that these are 2 different types of data, right? And you could imagine that you could write some kind of a rule that would differentiate between them. And I actually will explain a little bit let's see if my cord will reach. Yeah. So this one on the left, these streaks that you're seeing, those are English letters. So this is unencrypted website. So all of the English letters are very popular, and then above and below that are non-English letters. And so you can just see by looking at this streak, oh wow, English, like there's a lot of English in this website. And even if it were not in English, like all the protocols that the web is built on are in English. So all web traffic has a bunch of English letters, even if the website itself is in another language. This over here is encrypted web traffic. And so a couple of interesting things about that. One, you don't see these streaks because English letters are not more popular than everything else in encrypted traffic. That's the whole point of encryption. However, you would think that encrypted traffic would just be one big white noise blur, and it's not. It has a lot of structure to it. And that's a misconception people have about encryption. They think that encryption hides everything. It actually only hides the content, and it has a bunch of stuff around it like metadata, which is not encrypted. So you can easily look at this sort of thing and you can tell that it is encrypted data. It doesn't look just like totally random. So we can go ahead and we can analyze this data with our brains, and we can like write a rule that will classify something as being one or the other based on these characteristics like prevalence of English letters and things like that. But wouldn't it be nice if we could just have an algorithm that would create a mathematical model based on observations? Yes, we do. We have the machine learning. And so, basically we take all the data that we get from all of these vantage points all over the world. We throw it into like 3 lines of code on Apple's AI system. It like accelerates it to like use our GPUs and all our CPUs and everything, and then it like crunches all the data, and then in the end we get this model that can classify things as being one or the other. So once we have that, so essentially what we're doing is we're reverse engineering how the filters work. Like we're finding out what traffic it blocks, what traffic it doesn't block. Then we're using machine learning to create a virtual version of that filter and its settings to say like, okay, we can now use this in the lab and pretend that we're in Australia or whatever hypothetical place we were in, and it will act as if we're there, as opposed to having to like actually go there and test. We'll go there and test later, but first we'll do it in the lab with this machine learning model. So implementation is very straightforward, right? Once you have this model, all you got to do is you got to say, okay, let's find some program that we put in our weird internet traffic that looks like this encrypted web traffic, which is banned, and it transforms it to look like the thing on the left that we know that the machine is going to be fine with. That's all we got to do. Is this possible? Of course. It's just some data and some code. It's a simple matter of writing the correct code that will do whatever this transformation is. We could do that. Like we could figure that out and we could write that, or we'll just let the machine learning do it. Because it turns out the machine learning, there's a dual. So anything that can classify things into categories, you can also tell it a category and it will make things that would belong to that category if you were to classify them. So essentially we automatically generate these adaptive systems based on the data that we process. And so you may be skeptical. You may be like, can a machine learning system really like generate something automatically with all this magic that's going to like actually fool machines into thinking that the traffic is like total legit traffic? And the answer is yes. This picture of cats I showed you earlier, all machine learning generated pictures of cats, no real pictures of cats. You were all fooled. You thought they were actual cats. So if we can fool all of these smart people in the audience, we can definitely fool like a little Linksys router, with operating system that was made like 20 years ago. No problem. We got this. And that concludes my prepared remarks. We can take some questions. Yes.
So where is the traffic being adaptively transformed?
Where is the traffic being adaptively transformed? Okay, so there's 2 parts. So there's something that you run on your computer that intercepts your network traffic before it hits the actual network, and then it transforms it in code so that what actually goes across the real internet is the transformed traffic. Then you have to have a proxy server on the other side, right? And then the proxy server has to speak this protocol as well, and then decodes it. I'm just trying to get to this proxy server slide. This is actually very important, this notion of proxy servers. You're always going to have between you and the end destination, somebody that you go through first. You always have to have that because they'll just block the numerical address of your destination. It's the easiest way to block. So if we're already going to go through a proxy, we might as well put in this special proxy that speaks our weird like adaptive protocol that we made up. And so it's decoded on that end and then sent on to the end destination.
All right, so in your map of cables,
yeah,
right, realistically, it's going to be a multi-hop trip for a lot of data. Like for us to sense in Australia, I don't think there's a single cable between Austin and Australia, right? So it may need to move through several sensors or filters along the way. How are you going to transform the data to fool each of the sensors along the way?
Yeah, that's a very interesting question. So that is not currently a problem that we see very often, because usually what the adversary that we're dealing with is you're in a country which is censoring your ability to connect out of the country. So once you connect out of the country, you will connect to the closest, like one hop away in terms of the big cables country that has open internet access. Now, it is true that most countries are increasing their aggressiveness of their filtering. They're blocking more and more things. So I could see in the dystopian future that we are living in and moving towards, I could see there being a situation where, where the only place you can proxy into also has filtering, and then you need to do a two proxy system. We have not encountered that yet, but it's a good thing to think about, because I do think it will probably happen eventually. Yes.
So what you're doing is obfuscating the data within the packet, but when you turn it sideways, you can still see, that's torrenting, or that's Netflix. So how do you avoid the pattern matching that the adversary is going to be using to determine whether you're video conferencing or whatever?
Yeah, so that's a great question. So there's a certain characteristic of your internet traffic that can tell what you're doing, regardless of whether it's encrypted or whatever. So Netflix is a great example. On Netflix, you say, here's the movie that I would like, and then it's 3 hours of data in the other direction. That is a very clear sort of pattern. Whereas if you're doing something interactive, like loading web pages, it's a very chatty, I'd like this page, here's the page, I'd like this next page, here's the page. So this sort of thing, it's much harder to hide. It's easier to hide web traffic inside of say fake Netflix, because you have this big amount of data that's being transmitted that you can hide your tinier bits of data in. But to hide a Netflix video stream inside of someone checking their email would be it's just not possible from an information theory standpoint. You'd have to basically, instead of having a stream, you'd have to very slowly download the video over a long time and then eventually watch it. So that traffic shape sort of thing is one of the most difficult things to hide. In my dissertation work, I worked on that, and essentially there are some streams that you're not going to be able to do, and there are some streams that are lower bandwidth that you can hide by basically sending data when you don't have to, and then also throttling the data when there's too much data. So it's possible to do, but what we do in our modern adaptive systems is we don't worry about that, because it's not part of our threat modeling. So in our threat modeling, which is about this oppression-based, human rights-based censorship, we don't see people blocking your access to view Netflix. They're blocking specific websites. It's an interesting problem, though. Kevin.
What are your thoughts about some of the anti-censorship schemes we see about trying to obscure a lot of the metadata information, stuff like DNS over HTTPS, or encrypting the server name identification field?
Yeah, we're actively working on all that stuff. That's a great area. So a big weakness of the internet from a censorship standpoint is this name system, where nobody wants to remember numbers. You just want to go to Google, and then it will figure out the right number for Google server, and it will connect to it. This is a very insecure system that we have. It is very easy to break, and the adversaries do a lot of stuff. So not only will they block your access to these, by name, they'll say no Google for you, but they'll also do this poisoning, where when you try to say, what's the address for Google? They'll be oh yeah, we got that number. It's our number at the government. Why don't you call us on your computer, and we will serve you web pages that we assure you are definitely Google. Very, very real, very common thing. They used to just redirect you to a site that said, hey, you're not allowed to access this. But now they'll do stuff actually, you try to install a circumvention tool like Tor or a VPN or something. They'll take you to a fake website with a fake version of that software. It may actually be the real software, but with malware embedded, so that when you install it, you're yes, you're on a VPN that goes through the government's monitoring station. It's it's a real problem. So yeah.
I'm not a computer engineer at all. How do I know as an ordinary citizen if that's what's happening when I go to Tor?
Yeah, it's a great question. And so in some countries, they will block all legitimate websites where you could download the software, and the only software that you will see is from illegitimate websites pretending to be legitimate ones. So there's, in some places, in some very extreme situations, no way using the internet to actually get the software. And so what we do is we work with human rights groups in the country that have access to the people, and we can tell them, like, here's the software, and they have like a mechanism to get it to the people. People that are just randomly Googling, like free VPN, don't use a free VPN, by the way. Never use a free VPN. There are no good free VPNs. You got to pay for a VPN. VPN is, like a proxy tool. Anyway, just like with everything, it's like you got to buy it if you want it to like not be stealing your data. So anyway, what was the point? Yeah. So yeah, there's not really a way to tell if the stuff you have has malware in it or not when you're in that situation. In some places, the way that you get software is you buy a computer and it comes with all the software already on it. And so it's all malware. Like the idea that you own your phone and that you get to decide what is on your phone is like a very American perspective towards device ownership. In some countries, like your work gives you a phone, and that's how you get a phone. And it has all kinds of both government and work related like spyware on it. So you need to have essentially like a separate device that was not provided by your job or like by the phone company or by the government.
Even here in America, oftentimes government agencies will give you like a phone for free as part of your job, but one price for that is that they basically can see everything you do on that phone. Even here in America, like Texas state government does that. And also, this is not a solution for all fake software, but this is actually one of the benefits of like downloading open source, all things like GitHub. You can check the checksums of the signing keys and make sure that it's authentic software, that you're really downloading what you think you're downloading.
Yeah, unless you get the checksum from the same fake website.
Correct. So this is a little bit of a tangent from my presentation, but we are working on this open source hardware secure cell phone. So people that if you don't trust your phones to not have malware on them, you can get one of these. You can order all the parts for this yourself, build it yourself, install the open source software. You don't even have to trust us that we didn't put malware on it, because you don't have to get it from us, and you can like check all the source code yourself. But this isn't out yet. This is like just a sneak preview for people in the room. So like don't take a photo of that or anything. Yeah.
You just teased my paranoia a little bit, but maybe I misheard it. Like, so even like a pay VPN, like NordVPN or something, like is potentially like going through the government, or the ones that you pay for, like.
Okay, so all free VPNs are definitely worse than using nothing. Please don't ever use one.
$100 a year.
With the paid VPNs, if you actually went to the actual VPN website and actually got the software, and it's not fake software from a fake website, there are VPNs that are better than other VPNs in terms of, like, when you're using a VPN, what you're saying is, I trust this company. I don't know them. They're just, there's some people somewhere. I trust them more than the people in the Starbucks that I'm trying to get on the access with. I trust them more than this access point in the airport that says free airport Wi-Fi, but might just be like, I can set up a thing that says free airport Wi-Fi right now in this room. That doesn't make it real. Yes, I use, well, no, I don't run a VPN, but yeah, TunnelBear is what we use. It has a little bear that pops up whenever, yeah, so like, oh wait, I was going to show you TunnelBear. Virtual private network. Yeah, so I was trying not to use any internet acronyms, but they slip in. See, we don't take the absolutism perspective, though, on privacy, because if you look at what people are doing in these countries, like, people will do whatever it takes to get internet access, to get like information access to like credible and topical sources of information. They'll do whatever it takes. So like, they are doing super insecure, privacy destroying stuff all the time. Like, for instance, Googling free VPN and just downloading like the first thing because the internet was working fine, and then it went out in the whole country and they're like not prepared. People are using like unencrypted, just normal text messaging to like I've talked to journalists that are text messaging like, I'm going to go to this place at this time, please, I hope no one kidnaps me, and they're just sending it out over the unencrypted text messages. And in some countries where they have failed governments, if you're a criminal organization, you can just go pay cash money and get access to the government level, like cell phone intercept technology. Like the idea of like having to have a warrant and everything is a very cool American idea that I love, but is not the reality like in some places. And so the idea that people are just like texting their location is like, makes me so upset. But so what we look at is harm reduction, like reduce the risk of the user. We will not give them technology that we think will increase their risk. In most countries, the technology that we make is legal, and it's like not going to get you in trouble to have it. Like most places that block the internet, you can have a VPN. It's fine. They'll just try to block your VPN too, but they're not. No one's going to come to your house and say. And this is different for every country, but in the countries where we try to work in, it's like no one's going to come to your house and be like, "Oh, you got a VPN and you're in trouble now." No, they don't care. They just like essentially the way internet filtering works is somebody with political power calls up the internet provider and says, shut it down. And the internet provider will say, okay. And that's basically, a lot of times it's not even legal to turn off the internet. Like there's no like act of Congress or Parliament or anything that gives anyone the power to shut off the internet. But, you just call people and say, do it. And then they do it. And then it's broken. Yeah, it's just broken. And so this is like the common, way that these things happen. I mean, there are some exceptions. So like, for instance, in my sister was just asking me about this, in Dubai, VPNs are not allowed, and like teleconferencing is not allowed, and it's not allowed because they don't want you to be using Skype instead of buying a long distance plan, right? Because they have a government owned like telecommunications monopoly, so that's why it is not allowed. It's not even meant to be any kind of like oppression. They're just like, hey, don't use this free stuff, like pay us money. So what was my point about Dubai? Oh yeah. So if you come into Dubai and you have Skype on your phone, they actually look at your phone and delete it. So like, that's an example where like, you can't just, sneak it in there. Like you have to buy a phone that's already in the country that already has Skype installed on it. Cause also there's no app store in Dubai. So you can't download it. Like you're just out of luck. So there's some exceptions, but for the most part, it's kind of like a technological chess game between the people on our side that are trying to circumvent the filters and then the people that are making the filtering boxes. And they're actually, I think, kind of excited when we defeat them because then they can sell more filtering boxes because nobody wants to upgrade their filter. They spent like $20 million on filtering boxes and they like never want to upgrade them. So, but yeah, it's like, it's just this, it's not as political as it sounds. It's really more of like a chess game between these two like sides of hiding and like finding. It's like a cat and mouse sort of thing. Yeah.
So my understanding, because I don't know anything about this, but it seemed like you were saying that you could translate that which is encrypted into something that is understandable. Is that what you were saying?
Yeah, I think that's a good way to look at it. So the point of encryption is to take things that are easily understandable and then make them look like random noise. So what we do is we take random noise, which is the encrypted stuff, and then we turn it into something that looks not at all random, and that's kind of our magic secret sauce there.
Brandon, what role does the so-called dark web or undernet play in here, where you have sort of like the sort of constantly changing but somewhat synchronized network of servers? And does that play into your strategy at all?
Yeah, so when people talk about like the dark net or the dark web, it's a very nebulous term, but usually what they're talking about is the websites that are accessible through Tor. And Tor is a great tool, and everybody uses it on all sides. So like, it's true that cyber criminals use Tor, but also like police departments use Tor to like catch cyber criminals. It's they're on all sides. So it's a very popular tool, and so one of the problems that Tor has is that Tor is blocked in a lot of countries, again, through protocol identification. So they look at the traffic and they say, oh, that's Tor. We don't know what you're doing. We don't care where you're going, but we know that you're using Tor, and so it's like blocked. So Tor actually came up with the basis for the technology that we're now developing. It's called Pluggable Transports. And Pluggable Transports are basically a software module you can slot into your software to do this obfuscation on your traffic. So it's actually invented by Tor for their own uses, and they decided to work with us to make it a standard that a lot of different tools can use now. So like TunnelBear was like the VPN provider we were talking about before. They have Pluggable Transport. They call it GhostBear. So if you go into your settings, you turn on GhostBear, that's turning on this Pluggable Transport technology. So a lot of different people are using it. And so it's really like in that side of things, like it's just that first connection to the Tor network, which is the one that's blocked. And then once you're into the Tor network, then that's like, like once you get into it, then you can access all of these like, like secret sites and all that sort of stuff.
So it's basically proxy middleware is what it is?
Yeah, so like essentially you can't connect directly to the Tor network because of this protocol identification attack. So you proxy first through one of these pluggable transport providers and then into the Tor network. And so, yeah, so that's something like we work with Tor. We go to all the Tor developer meetings and everything. And we have a lot of good friends in the Tor community, very big open source community, Tor.
How much would you say, like the kind of blocking of access to information that we know is prevalent in some countries, do you feel like that's happening in ways that we're not aware of here? Like, can you speak to that a little bit?
Yeah, so America has the best internet. I travel all over the world and go to places that block internet. We have great internet access to the point that a lot of people don't even know that there's a problem. And like when I try to describe the problem, they're like, what do you mean you can't access YouTube? That's insane. And it's like, well, I'll make many countries like block access to YouTube because YouTube, somewhere on it, has a video that the government doesn't like. So they just said, we don't need that website in our country at all. So we have great internet. The only times that I've experienced censorship that I would consider, like on par with the sort of stuff that I see, like as political oppression, is actually it's corporate based. So if you're accessing the internet on like a coffee shop internet or like an airport internet, and that internet is provided by one of these third party, like we provide internet to coffee shops providers, sometimes they will just go ahead and put some filtering on there. Now in some cases like libraries are federally mandated to install filtering software. They are not federally mandated to filter any specific sites, but they have, if you want to take federal money, you have to have the software in there that could be used to block stuff. And this is a big thing. Like my PhD is from the library school. So like librarians are like very into this debate of like, free information access and, like appropriate filtering and stuff. But in the case of these corporate filters, they just like throw something on there and who knows what it's blocking. And I'll tell you what it's blocking is a bunch of websites that I need to go to. So like, for instance, all of the circumvention tools, all of the like VPNs, all of the tools that let you bypass blocking are blocked by anyone that does blocking because they don't want you to bypass their blocking. So why coffee shops think that they need to keep me from like accessing these things, I don't really understand, but it's just one of these like default policies. And the bad thing about it is because it's not a legal process, there's no way to appeal. Like if my website is blocked by one of these like providers of blocking, I can't go to them and say, hey, you made a mistake. My website is great and totally appropriate for everybody and you shouldn't block it. There's no process because no one decides and no one even knows. It's proprietary what the list of blocked things are. So there's no way to even know without testing what's blocked. I always like to say, the point of companies is to monetize things. So if it doesn't have advertising now, it'll have advertising later. Like if you can data mine the data, you're going to do it because your shareholders want, that profit. So you got to protect yourself and you got to put in, tools that protect. So I use a VPN even like at home. I use it everywhere because I don't trust any ISPs to not be mining my data. So I just like everybody that works at Operator Foundation gets a free VPN, like the day that you started, you can just like always use a VPN all the time, which is not a 100% solution, but it protects you from the local threat of the coffee shop or the airport or the hotel or your home internet provider, like data mining you.
Why would you trust Bear more than Rondo?
Right, yeah. So why would you trust the VPN provider more than you trust the local adversary? It's a great question. And I'm not saying that you should trust them with your data. I'm saying that when you should use a VPN for sure is where you don't trust that the local network is secure, and you don't trust that like people like, so for instance, is it even a real hotspot? And you know, is it like even run by the establishment you think it is? Is it encrypted in a way where people like on the Wi-Fi aren't going to be able? Well, so here's a terrible story about somebody that I used to know. Terrible person. He used to go to Starbucks before Starbucks Wi-Fi was encrypted, and he would like watch people like going on Facebook, and then just like sidle up to some lady and be like, "Hey, are you into rock climbing? Because I'm really into rock climbing." Very successful strategy, dating strategy. I know he's the worst. He's the worst person, but very successful. And now they have encrypted Wi-Fi. But you don't want that kind of stuff happening. Hence, you should encrypt all of your data. But it's true. It's like, is TunnelBear selling our data? Yeah, probably. Yeah. I don't want to say that about TunnelBear because I really like them personally. Like all the people that work there are great. But you know, who knows? Who knows? There's no assurances. And that's why you should also be using encrypted web traffic over the VPN. I don't know. There's layers and layers, you know, of security that we could get into. All right. Well, let's wrap it up, and thank you everybody for coming.
Learn more about the Operator Foundation at operatorfoundation.org. You can stay in touch with Plutopia at plutopia.io. On Facebook, look for @Plutopia News. On Twitter, it's @Plutopia. With John Lebkowski, I'm Scoop Sweeney. This is the Plutopia News Network, 20 minutes into the future.